Okay, welcome back everybody. Perhaps someone could just check we have good sound and vision again.
Yeah, everything is good.
Good, thanks. I hope everybody had a reasonable lunch. And if there are any questions arising from this morning's stuff, please don't hesitate to ask. But we'll go on now to have a look at the afternoon's content. There are three quite substantial issues addressed here. How to submit jobs with a scheduler, and the slightly separate issues of debugging and profiling. Depending on how we go, for the sake of people's concentration, I may move profiling off until tomorrow morning. We'll see how we get on. Okay, so scheduler. So as a shared system with a large number of users, we require a scheduling system to make sure everybody gets fair go, as they would say in Australia, to use the system. And so this requires essentially writing a job submission script, the control of jobs, and understanding a little bit about what resources are available. Now, for those of you coming from ARCHER1, the scheduler is PBS. ARCHER2 has moved to a different one, which is Slurm. So whereas on ARCHER1 you had things like QSub to submit a job, QStat to review what's in the queue, these are replaced by analogous Slurm commands, and these are listed here. So there is a general one, sinfo, which is a general command to try and obtain information on the current state of the system from the point of view of Slurm. So sbatch is to submit a job, so that's the analog of QSub. SQ is to interrogate the queue to find what jobs are active. So that's the analog of QStat. Likewise, if you want to cancel something or delete it, that's the analog of QDown. There are also a couple of extra ones associated with Slurm, which is salloc, which is a command which will basically make you an allocation in the queue system to run quotes interactive unquotes jobs. And there is also srun, which has slightly dual nature in Slurm. It's used as the job launcher, so the analog would be AP run in ARCHER1 terms, or MPI exec or MPI run if you're coming from a standard system which uses that model. srun can also be used in the context of interactive work. We'll see these. So without further ado, we can have a look at what's going on over here. So here I am logged in as I was this morning. I can issue sinfo to find out what's going on, and that is conveniently just filled one screen's worth. So there's a series of columns here essentially, which are slightly hard to read. First partition, then availability or time limit, number of nodes, the state of the partition, and the node list. So most of what you sort of see here is actually for each state and partition. There's a list of nodes, which is cluttering up the screen and is not actually perhaps of huge interest, and will only get worse as the number of nodes increases. I happen to have a slightly separate incantation here which controls the output. You don't need to worry too much about this. Just makes the output a bit more manageable by avoiding the node list. So here we are. This is essentially the same thing. So we have at the moment there's essentially only one of these partition things. So you can think of this partition as a collection of hardware resources. So at the moment this includes the nodes, which are the back end or the compute nodes, and those are the only partition. If the GPU add-on machine arrives, that would probably live in a separate partition because it's separate hardware. Availability, everything's up. There is a time limit associated with the partition. I'll say a bit more about time limits in a minute. And then there's a number of nodes in a certain state. The main contribution at the moment is 884 nodes are allocated. That is, they are being used. 57 are idle, waiting to be used, and a number of nodes are in various states of brokenness at the moment, with these down states, and there is also 35 nodes are reserved, so that's a reservation. Some of those nodes are a reservation for this course, so if the machine was full up, we could use those nodes, especially reserved for us. But actually today, as there are a significant number of idle nodes, we should be okay to just not worry about the reservation. So that's more or less that. So I think I've said most of those. Yes, so the time, the Slurm format for time, reading from right to left, is seconds, minutes, hours, and days. So this time limit on the partition is 1 day, or 24 hours. We'll see also when we get to submit some jobs, there is a concept of quality of service, which you can think of slightly hand-wavingly as the queue. So there is a standard quality of service option, which is the default queue, The other one you should be aware of is the short quality of service, which is doing the job of the short queue with a 20-minute limit. So part of that reservation there is accommodating the short queue. Okay, so that's basically what I've said, I think. I don't think you may occasionally see nodes reserved for maintenance by the systems folks. Okay, so you can try these things out if you like. So ninfo minus capital, oops, sinfo even, minus n minus l will give you a rather verbose list, which is with one entry for every node. So there will be about 1,000 lines for this. So if we have a look at the example we just got here, for example, the node is here. This tells you which partition the node is in. This particular node is idle at this time. There is a column here, CPUs, which is saying 256. So Slurm has a concept of CPUs, which can be thought of as places in the hardware which can accommodate threads. So while the physical hardware is described by 128 physical cores per node, Slurm has a slightly different view of this, which is set out in this slightly cryptic heading here, which is S for sockets, C for cores, and T for threads. So we have 2 sockets, each of 64 physical cores, making 128 cores per node. But we also have this extra factor of 2 here, which is indicating that each physical core can support 2 threads in hardware. So if you multiply that out, you get this 256 number, which Slurm is going to refer to as CPUs. So it's a kind of product of physical cores, and 2 threads per physical core are possible. The next column is memory, which is over here. So that's approximately, actually, if we look over here in the true situation, it is saying 256 thousand which is indicating that we've got 256 gigabytes of memory in the node. I think the other ones we don't need to worry about. So that's one way of getting a little bit more information about each node. So there's a wee exercise here which you can have a go at. So that NID 001005 should be okay for this exercise. So you should have a go for that. Oops, 01005 I think is okay. And then this -O option is specifying the format of the output, and the incantation here is %n, which I suspect is the node description, C, and %m, which gives you CPUs and memory respectively. So the first question here is irrelevant because there are no high memory nodes, other than all the nodes have the same amount of memory available. You could try the other one. So there are various ways to try and find out which are the free nodes. We've seen the most obvious one is sinfo, which should tell us that these 57 are idle at the moment, but you could also do that in different ways. So, for example, if you want a long list of all the nodes in the idle state, you can select them via that. Not that you probably ever do this in anger on the real system. Okay, on to actually submitting a batch job. So, as I said, you'll be familiar with coming from ARCHER2 using PBS submissions. So it's the same kind of game for Slurm. One wants to write a standard bash script, in this case introduced with shebang/bin/bash there. And I've given a little example here in which we have these special tokens, hash sbatch, which looks like a comment as far as bash is concerned, but will actually provide options to the queue system, and all the options are introduced with -- something typically. So here's this partition thing. So I'm saying this job I want to submit to the standard partition, and for the purposes of today we're just going to use the --QoS. This quality of service is standard, and this is generally what you would do for production work. There is also the short QoS, so for development, where you're doing short tests, you may wish to think about using the short QoS, for which time limit is 20 minutes. There's a few more options here. So this one is just setting a label, essentially, by which you can see the job in the queue system. And we have to specify to sbatch something about what resources we are actually requesting, so that Slurm can make the appropriate reservation, can do the appropriate scheduling. So I'm saying here I want 2 nodes. I want to run 128 MPI tasks per node. So that's my intention, is to run 1 MPI task per physical core, which is probably what you'd want to do in practice. And I here specify a time limit in hours, minutes, seconds, so that's 10 minutes. Okay, so that's all I'm going to do for this example. So we provide a special module here called EPCC job env. So what this is effectively doing is restoring the default programming environment, which is programming environment cray. So we'll see that in a minute. So as I said before, when you do that, you can go ahead and use the modules as usual. We're going to, as an example, use this thing which is called XTHI, and this is just a little utility which actually reports the placement of MPI tasks and also threads on the hardware. I'm not going to actually care about too much about what that the placement of the various MPI tasks at the moment. We're just going to use that as an example, and you'll see that is launched with this S run. So you should be possible to, for example, cut and paste that with your favorite editor. Here's a file. You can use VI or Vim. I think Nano is available, Emacs. The easiest way is probably just to paste that in to there. So I think that looks okay.
Do you need an account code?
Yeah, so the policy would suggest you should have an account code with that. However, I happen to know we can, at the moment, you can get away without that, and it will get charged against your default account. That situation may change in the future, and you may be forced to specify an account. So we should be able to go ahead and submit that job like so. That tells me it has returned me a unique identifier, which is, if I'm quick, I may be able to examine the contents of the queue with SQ to look for my job. So it may have finished already, but as it's only a short job. But let's have a look. So that's the full output of SQ. Let's make the screen a bit wider. See if we can get it all on. Let's see if we can get it all. No, not quite. Maybe. Yeah. Okay, so here's SQ. You can use your either your job ID or your name, which you specified in your in your job name option. This is the user. This ST is the state. So these are all PD is pending. Obviously, if it's pending, it hasn't used any time yet, so time is 0. Number of nodes requested, and for running jobs, you get a node list, a list of the actual nodes you're running on. If you're pending, Slurm tries to give you a reason why you're sitting in the pending state. Some of these are more transparent than others. So this association max CPU minutes per job limit, I confess I'm not completely sure I know what that is referring to. So there's a job here which is saying resources, so that's asking for 90 nodes. So I suspect there are not 90 nodes available, so that can't run. If you're in priority, that's the usual state. You're just waiting for your turn. Some of these guys here have a dependency, so within the submission script, one of the things one is allowed to do is express a dependency on a condition on a previous job. So for example, these may be waiting for a previous job to finish before they go ahead. So that's it there. There's a job that has been held by the system administrators there. They will do well to get 1,024 nodes on the machine at the moment, I think, that user. And here are the running jobs with R. So this one's been going for over 23 hours on 5 nodes and so on. So I suspect at the point that I typed this, my job had already finished. So we can have a look in the current working directory in the work file system. We should have found that the output has appeared here. So we can have a look at that. To check that something has happened. Okay, so you'll hopefully recognize this from this morning. This is the default programming environment coming back via module restore. If you wonder where that is coming from, it's actually coming from there, which is one of the things that does is to restore the programming environment. The rest of the output down here is the output of this thing, XTHI. So this is telling us that indeed we've asked for 2 nodes there, and we have got 2 nodes which happen to be those 2. And for each node, hopefully, it's going to report 128 MPI tasks. So I'm not going to worry just yet about, so this affinity is showing where in the hardware that MPI rank is sitting. I'm not going to worry too much about that just yet. We'll come on to that. There's again a wee exercise here to get you used to this business. Hopefully not too difficult. If you haven't done so already, I suggest taking a copy of this example, and you've been asked to if you remove some of those options from the script, you should be able to discover the default number of nodes, which is allocated by Slurm, and the default number of tasks per node that Slurm would use. As a slightly separate question, you can try and find out what is the default time limit for the job. To do that, you'll actually need to look at them, probably need to look at the man page for this command, saccount. The other thing you could try to do is see what is the minimum viable submission script which can be submitted without error. So have a go at those. Have a go at those. And if you've got any questions, just type them into the chat as before. So hopefully this is not too problematic. To find the default number of nodes, I can probably take out the nodes, the explicit node option there, and submit that one. If you want to limit yourself to your own jobs, you can use SQ-U and then your user ID, which for me today is this one. I think that's right, Kenneth. So that's, if there's nothing in the queue, it means it's probably finished. Yep. So I've removed the explicit minus nodes equal to option. So if I look at the output, I can see by default I've just got one. And I should still hopefully have 0 to 127 in the MPI ranks, which is still true. Likewise, if I were to get rid of that option, which is specifying the number of MPI tasks per node, that will tell me what the default is. Anybody work that out yet? And type it into the chat. So if I have a look at the output for that one, somebody's got the answer yet? Yeah, well, yep, good. What is it? 5951. Out. I get one node, one MPI rank, so that looks like the default. Rank 0. This wall clock time limit is slightly more taxing, and as I say, you may need to look at the man page for S account to get that. Because I have specified a time limit of 10 minutes there, if I want the default, I'm going to take that out and submit the job again. You notice, because I've taken the time limit out, there is actually a warning that you haven't specified a time limit, so it's always good practice to try to have an idea about how much time your job is going to take and to specify an appropriate time limit. However, that is just a warning, and the job has been submitted. So we could attempt to obtain some information about that job, which would tell us what the time limit was. So there is a command S account for which, if you give it a job number, which for us here is 59154, it gives us some information on the job, which is here. So that was the name that we set in the submission script. That was the petition. Here's the account. So there, it's gone. It's because I haven't specified explicitly an account. That's the default account in this case. It's finished, and it finished successfully with exit code 0. You'll notice the actual executable here appears as so-called job step with 0.0 after it. Okay, so that still hasn't told us what the time limit was. Anybody got it yet? Anybody got it? Let's have a look. So I think the correct incantation, if you look into the man page to get the it's something we want output, which is time limit, and we need to specify the, which job was it, 59 154 again. So that tells us that because I didn't specify a time limit in my submission, the default appears to be 1 hour. that's slightly tricksy question, actually, slightly tricksy. In real work, you should always specify a time limit to avoid. So if there's a problem with the job, and it, for example, deadlocks, you don't want to be wasting a lot of time by not specifying a time limit. Okay, last part. Anybody found out which options cannot be omitted yet? Yes. So that's yeah, okay, well done. I think people are zeroing in on the minimum viable batch script is probably that one, in which you must specify a valid partition and a valid quality of service. If I were to take those out and have the following script, I'd be in trouble. Just to drive the point home. Oops, script. This time I'm getting an ugly message which is telling me I must specify a partition name. So I better specify a partition name. At this point, it's perhaps worth noting that one is perfectly entitled to do that, but one is perfectly entitled to specify these options on the command line to sbatch. So that's the equivalent of putting this hash sbatch special token in the script itself. Okay, so that's still not good enough because we haven't specified a QoS, so I would have to specify a QoS to if I can spell, it would help if I could spell. That one gives me this warning about the time limit, but that one should be successful. Okay, so you must specify partition and QoS. So hopefully that's clear. If you have a job in the queue which you realize is erroneous or has gone wrong in some way, you get rid of it with scancel. So like so, and I suspect that's finished anyway. But I suspect that's, yeah. Okay, so hopefully that's all clear. That's basically how one submits a job. So far I said we weren't going to worry about exactly where these MPI tasks ended up. For real work, we probably do care, and we care for performance reasons because we would like our tasks or threads to be organized in a manner which is consistent with good performance. So there are various ways to do this, and this involves the interaction between options provided by or provided to SBatch and the possibility of additional options to srun, which is the parallel launcher. So again, for those of you coming from ARCHER2, there is a fairly clear dichotomy between what you specify to PBS to control the allocation requested from the queue system and the options you specify to AP run to actually launch the parallel executable, or to specify the configuration of the launch. In Slurm, these issues are slightly conflated, in my opinion. So what srun is actually doing is looking at the information that has been provided to SBatch and trying to work out a configuration to set how the application is going to run in terms of which tasks and threads are bound or assigned to given hardware. So perhaps the most simple way to do this is to use this command or option rather to srun, which is ---- CPU bind, and then you specify a type of binding. So for in this case where we are considering simply an MPI program, the easiest way to do this is to specify CPU bind equals rank in this way. So if we go back to the case where we're asking for 2 nodes, each running 128 tasks per node, and you specify CPU bind equals rank, you can see what that does. So perhaps if we just have a look at what happened in one of our previous attempts. Say that hopefully that one. And we concentrate on what's going on here. So you'll see here, reported over here, is this so-called affinity. So this is telling us where in the hardware each rank and thread is being placed. So you should carry a mental picture that the physical cores are labeled 0 to 127, but we have this additional issue of the possibility of running 2 hardware threads per core. So Slurm also is aware of what we might think of as logical CPUs 128 to 256, So it so happens that logical CPU 0 and logical CPU 128 both sit on physical core 0. So that's the way it's looking. So you can see here, without any option to srun, it's done something slightly curious in that rank 0 here has been assigned to physical core 0, which also involves the hyperthread, if you like, core 128. Rank 1 has been assigned to physical core 16. So that's probably not quite what we would imagine. So the way to control this is to use this, or at least one way to control this is to use this -- CPU bind equals rank. Hopefully people can just try this out. So I need to restore a valid batch script. As a good citizen, I should specify a time limit, and we want 2 nodes, each running 128. Whoops. Per node, and I want to specify equals rank, like so. So hopefully by now you've convinced yourself that that does something reasonable. And the second part of this question, so what happens, for example, if you try 8 tasks per node, say? Anybody got that yet? Anybody? So with my CPU bind equals rank, hopefully one can see that this now looks slightly more sane and rational, in that for each node, rank 0 has been bound to the corresponding core, which is more like what we might want for an MPI application. Likewise, by the time we reach the second node, this is rank 128, and then the placement is worked out appropriately for the second node. So if you've done the second part of that little exercise, anybody got it yet? So there's a question in the chat, would it affect performance to have the task or thread map to the CPUs in that default order? Well, it's a good question, actually. It may depend on how your MPI decomposition has worked out, but certainly for it's probably conceptually easier to believe that things like data locality will be improved if there is a ordering of ranks to cores which you can understand. The ultimate test, of course, would be to run a benchmark. Certainly, when we get to the question of having OpenMP threads, one really does care about where the NUMA regions are. Okay. Anybody got the answer to the? So hopefully somebody's worked out. So if you just ask for 8 MPI tasks per node, you should end up with output which still binds the rank to the corresponding core. So all 8 MPI tasks are going to be bound to cores 0 to 7. So that may not be what we want, because there, if one is doing this at all, it is probably to provide additional resources in terms of cache and memory bandwidth to each individual MPI task. And as there are 8 NUMA regions in the hardware, one would probably like to have the MPI tasks placed 1 per NUMA region, which is the would be the most obvious example. So that CPU bind equals rank is conceptually simple, but rather inflexible. So the next section, we're still thinking about MPI on its own. We could think about, well, how could we ask to get one MPI task spread out, and it's possible to do something like this, in which we just explicitly say to Slurm, please put my 8 MPI tasks in these positions. And that, so 0, 16, 32, 48, etc. would represent the first core in each NUMA region. So have a go at that and check that gives what you expect. And you could ask what you need if you wanted to run just 2 MPI tasks per node, and one or with one per socket, i.e. that would be you would need the correct map CPU option for that. So if okay, have a go at that, and then I think we'll take a little break before going on to discuss hybrid MPI OpenMP placement. Anybody got the answer yet? Anybody got the answer yet? Second part, anybody? I'm afraid I can't offer a prize today, but what do I need for one MPI task per socket with the map CPU option or type of binding? So I should remember to set in tasks per node equal to 2, and I need something here which looks like CPU colon. What do I need? Okay. Yep, someone's got it. Well done. Yeah. So if we do 0.64, that will give us the first. Hopefully, that will give us the first core on each socket. What am I doing? Hopefully that gives you some doesn't matter which one, not I doubt it. I don't. I assume all cores are created equal in some sense, but again, you probably want it at the start of the NUMA region in case you want to start threads. Okay, so that's an option. Obviously, again, that's fairly simple to understand. That could get a bit tedious if you had a lot of MPI tasks to specify. So there is a more general option to this minus CPU bind, which is minus CPU bind equals cores, which is the most perhaps general option, but that will bring us on to some of the ideas we're coming on to in the following section. Okay, so we're now at, since it's just after 3, I'm going to have a quick go back to the all right. Okay, I think what I'm going to do here is say we're going to now have a break until 3:30. Does that put anybody out of action? Does that? Okay, good. So we'll go on to look at the hybrid OpenMP MPI at 15:30. if you've got any questions in the meantime, you can always just type them into the chat. Okay, welcome back, everyone. It's about past. So we have remaining in the program today just this last part, which will discuss the scheduling of hybrid MPI and OpenMP jobs, and also a little bit about interactive use of the queue system. I think what I'm going to do is, since one or two people have had to leave already, I'm going to suggest a fairly radical reorganization of the schedule and postpone talking about debugging and profiling until 10 o'clock tomorrow morning, and I'll just finish off today with these two fairly short pieces, which are really just for information. So we should finish a little early today, but the main piece of content on debugging and profiling will shift to 10 o'clock in the morning, and these other short pieces tomorrow shouldn't take up too much time either. Okay, so hopefully that's okay with everyone, and will give us the maximum opportunity to keep everybody involved. Okay, so that we hopefully we've successfully submitted some MPI jobs. We just want to think now, if you are interested in hybrid MPI OpenMP jobs, we need to do something a little bit different to make sure placement of both the MPI tasks and the associated threads come out in the right place. Okay, so we've seen that Slurm has this idea of 256 so-called CPUs per node, which include 128 physical cores and basically a factor of 2 to allow that 2 hardware threads may run on each core. Typically, if one was running OpenMP work, the first thing one would do is assign 1 thread per core. There may be cases in which you wanted to actually try to make use of the 2 hardware threads per core, but it's not often you get any significant performance benefit or any benefit at all. So we need to try to think about spreading out our MPI tasks in such a way that we allow space for the threads associated with each task to be placed, and this involves this SBatch option CPUs per task. So this is going to say how many these Slurm CPUs are going to be associated with each MPI task. In addition to that, we're going to use the standard OpenMP environment variables to set the number of threads via OMP num threads, and typically this is the same as this CPUs per task. In addition, we're going to use this standard OpenMP environment variable to specify that the binding or the placement should be on the basis of cores, where each core is going to accommodate one or more threads. And so in this instance, we do not actually specify any minus CPU bind. To srun. So your first guess, so if we have a look at this script here, there's a bit of an exercise here. Your first guess, if I wanted to run 16 MPI tasks per node, that's actually, one imagines here there are going to be 2 MPI tasks per NUMA region, and one imagine that each one of these tasks needs to accommodate 8 threads, which we set here. So one can have a go at that straight away. So if I make the necessary adjustments here, 16. What are we saying? 8. We're going to get rid of the CPU bind, and we need to add num threads equals 8. Oops, let's get that right. Okay, so there's actually, you'll notice there's something slightly sneaky going on here. So this program is, in fact, a mixed MPI OpenMP executable, but before we didn't actually specify OMP num threads at all, which you may think is a bad thing, but actually one of the things this module is doing is to set OMP num threads equal to 1. So that in most circumstances is appropriate, but can occasionally lead to accidents if you're not expecting it. So that's what's going on there. So I think we should be able to submit that one. Ah, yeah, okay. Getting my cores, CPUs, and tasks mixed up. Okay, so that should hopefully run and produce a result. Okay, so what's happened here? Let's have a look. So something you can see rather curious has happened here. The first two threads associated with rank 0 have been assigned to physical core 0, which is also associated with this logical CPU 128. So Slurm, because it thinks it has these two CPUs involved here, thinks it can get two threads in there, but that's probably not what we want. We want one thread per physical core, so we would like this to read thread 0 affinity 0, thread 1 affinity 1, and so on. So we have to tell Slurm basically to ignore these extra logical CPUs, and the incantation for this is the following, as is given in the instructions for the exercise. So that hopefully should allow us to assign just one. That basically will make Slurm think I only actually have 128 CPUs to play with, which is more in line with the physical picture. So if we submit that one, what are we doing? We should be getting closer to the, not finished yet. Good Lord, don't tell me there's actually something. Oh yeah, so at this point we may actually want to use the reservation. Julian, I don't know if you have we've tested out the reservation in the background somewhere.
I do not know what the reservation number is for this one.
Right, okay, well, I better get that just in case.
But I'm pretty sure you could also run it in short.
Yes, probably could. So that's a good idea. So I'll demonstrate how this should be done. So if I were, if I want to, I am entitled to override on the command line what I've specified in the options. So I'm going to say I want this to go into short quality of service. The other thing I have to specify is reservation equals short QoS. Oops. Script. So that one will have gone into short and should bypass the congestion in the standard queue. See how we're doing. Yep, here we go. Right, okay, so we'd added this minus hint equals no multi-thread, and now you'll see the threads are assigned as we would hope. However, you'll notice slightly curiously here, rank 1 thread 0, which we might imagine would be affinity 8, has ended up in 16. So the next 8 have ended up 16 to 23. The next 8 after that, if I can find rank 2, have gone to 32 to 39. So you can see something actually slightly odd has happened here, and we saw a bit of this before. Basically, Slurm is dealing out the MPI tasks in a cyclic fashion, which it wants to distribute with a certain spacing. So the way to get around that is to add this, tell it to use a block distribution per node, and this is done with this distribution option. This is this S batch minus, oops. So there are two. There's this block here separated by a colon. The first block refers to the distribution between the nodes, and the second one is the distribution within the nodes. And the default for this option is a block between the nodes and a cyclic within the nodes. So I'm hoping this will if I submit that one to short again, I'm gonna, if I could actually spell, I'd be in fighting form here. Distribution, and we'll try that again. 59. You may have noticed that the turnaround in the queue is actually pretty swift on this machine. So the answers come out pretty rapidly, and hopefully this is now looking more ordered. So my first 2 ranks, each with 8 threads, are appearing in the first NUMA region physical cores 0 to 15. So there's a slightly complex procedure for making sure things, ranks and threads appear in the right place, but it can be important for performance to ensure that happens correctly. Perhaps the most common choice one would want on this machine, as I say, with NUMA regions of size 16 physical cores, your probably go-to selection would be 1 MPI rank and 16 OpenMP threads. So 8 MPI ranks per node. You can always try extending threaded performance to larger portions of the hardware. I have an application which actually has a pretty good threaded implementation, and that's effective up to about 32 threads, but not anything beyond that is really pushing it. So you probably go to first choice is 16 OpenMP threads to fill a NUMA region. Okay. Oh, well done. Oh, we only have another 10 minutes on the reservation. There you go. So someone, Ricardo, says yours is different, reporting slightly different affinity. Have you understood that one yet? No. So if you want to check your, I think there's I think there's a reference. So one that you could either put your script into the Etherpad, perhaps. I think there's a reference solution here, which you might want to try and cut and paste. But we can come back to that if it's still looking slightly weird in the end. So yes, okay. So that's that your sort of go-to configuration is for OpenMP is probably if you have a good threaded implementation, you should head there. A couple of so that's everything on placement. Can sometimes be take a little trial and error to get what you want, but that little XTHI utility can help you out to find out what's going on. Okay, so just a couple of other useful options if you want to specify explicitly output and error file names. You can override the default. The default is this just slurm with the job ID .out. If you so wish, you can override that. If you want to get the job ID, there's a magic token %j you can use in the file name, which will give you the job ID. I think that's I think that's actually the same as PBS. Okay, so that's hopefully will get you going and allow you to submit some work to the queue system. So that's in sort of classic batch mode, where you submit a job and go away and do something else and come back later and get the result. There are two slightly different ways of obtaining what you can think of as an interactive allocation in Slurm, and the first one is with this salloc command. So we can probably have a go with that, following the example. So the command is salloc, and you, in the same way, hopefully you should be aware that we must specify a partition. Whoops. We must specify a QoS, and I'm going to go for short again. If it's short, I need to specify the reservation. And then some resource requirements, minus nodes equal 2. I'm going to use what we had before, minus n tasks per node equals 28. My typing is criminal. And I should specify a time limit, because this is the short queue, not more than 20 minutes. I think that looks okay. So that's now going away and asking Slurm for a reservation, and you'll see here that we've been allocated 2 nodes, and Slurm is telling us these are ready to go. So what has actually happened here? Notice you can't. There's no visible sign of this. What has actually happened is this command has started a new shell, which is still living on the front end, and this shell, this bash shell, is able to communicate with our allocation, which is sitting on the back end. So we should, for example, be able to see in the queue system we have this thing running on the back end on 2 nodes. So I am now entitled to just go ahead and run some appropriate work. So if I have the appropriate module available, and I'm going to set equals 1. I can now launch with srun my XTHI program. That should go away onto the back end. There may be a short delay, and you'll get the results back as before. So that's a kind of way. So that allocation sits there in the background until it either runs out of time, or we can get rid of it by just exiting the shell. I like to do with Control D, exit, and that tells us we see this relinquishing allocation, and we now have dropped back to the original shell. So that's a kind of interactive job. That's quite useful for what I found that useful for is things like when running tests, some of which may be parallel and introduced with srun. Occasionally it's quite useful to use this salloc mechanism to do that. So the final thing is probably worth thinking. One is also entitled actually to run to request an allocation rather than using salloc. One can use srun. I'm just going to ask for minus one node. Here's another potentially useful option, which is actually the default. So exclusive minus exclusive, saying I just want a whole node with. I should specify a time limit. So what I'm going to do here is something slightly different. I'm going to specify what I want is actually a shell in the queue in the batch system with that incantation. And now if you're looking closely, you'll see something slightly different has happened. We've actually transferred control to a new shell that's actually running on the back end. So that might be slightly more what some people think of as an interactive job. So a further to make a parallel launch there, you would actually use srun again. So that's a kind of dual nature of srun. So that some people may wish to do that. Again, when you're finished, just exit and control is returned to the front end. Okay. Any questions? Yes. Okay. We'll have. Let's perhaps Julian can have a look. Julian seems to have disappeared for temporarily. We'll have a look at that one in a second. yeah, you might need an export there. Export OMP num threads may be required. Okay, so that's scheduler jobs. That's quite a useful stuff to understand, and hopefully that gives you enough to be able to do what you need to do. Okay. Okay, as I said, this is probably slightly too, debugging and profiling is probably going to be a bit too wearing on the concentration for the time we have left for today. So just in the last 10 minutes or so before we finish a bit early, I'm going to cover a couple of these short sections here, and that should more or less put us back on the right track. Okay, so how to be a quote a good citizen, unquote. So this is not hopefully too onerous a subject. One should merely try to remember that this is a shared system with finite resources, and therefore what you do can potentially inconvenience others if it gets out of control. So in particularly take-home messages, please do not run too much on the login node. So quick tests are fine, depending on what your quick is. A couple of minutes is okay. If it's a couple of hours, then you should be thinking it should be in the queue system. So remember that you can use standard Unix type things like kill, to terminate anything that looks like it's out of control. So just as a sort of quick quiz, one, just by looking at the name of these things, trying to think whether this would be appropriate to run on the front end, on the login node. So how about that one? Anybody think that looks okay? Good. I would say something that looks like a physics simulation is probably on the back end. Number two, make, is an interesting one, actually. So make typically invoked to build software is absolutely the kind of thing that belongs on the front end. The one thing to watch with make is that some build systems slightly surreptitiously think they want to make use of every possible core or thread in the system, and so we'll kick off 256 threads, which may be bad news on a shared system. So just watch out for that. A shell script, which is create directories, looks absolutely fine. Molecular dynamics executable, again, looks like something that belongs on the back end. Tarring up a file, again, generally. This one's untar, I should say. Looks entirely appropriate, I think. Those okay. So if there's any issues, just report them to the help desk. So for ARCHER2 management purposes, the help desk should be referred to as the service desk in official communications. So I may just fall into the language of help desk. The one thing to note about ARCHER2, like ARCHER1, is you cannot have any outgoing SSH connections. At the risk of stating the bleeding obvious, please do not share your login credentials. As you have signed the terms and conditions for the service, that is one of the terms and conditions. The other thing you should not do is any attempts to use SU will come to somebody's attention. This is increasingly noticed in people cutting and pasting commands from the internet to install software in our experience. So if you find yourself doing that, be careful. It is illegal to try and gain administrator access on a service where you do not have authority. So the other thing, just as good practice, rather than when submitting work to the queue system, instead of going for broke and trying to use 1,000 nodes straight away, run some smaller tests beforehand, so in case something goes wrong, you've got a bug, it won't be using 24 hours on 1,000 nodes before you find out it's gone wrong, which would be a waste of resources. Okay, so I think that's fairly again, if you have data which is mission critical in some way, you need to be thinking about how you might protect yourself against loss of data, particularly if that's on /work, which is not backed up. Typical mode of operation these days, most things of any value in terms of source code and so on tend to be in a revision control repository somewhere these days, which one hopes is well founded in terms of backup and so forth. So your data is your responsibility. We probably will not be able to do anything if something happens. So we went again through most of this this morning in the data transfer. So one other thing, just for folks who might be transferring data from ARCHER1 to ARCHER2, I mentioned this special network routing, which will be available, should give you decent bandwidth. It may be in the end that the limiting in transferring data will be actually getting data off the disk at the ARCHER1 end. So if you're seeing slow performance, it's not immediately the case that it is the network to blame. I think those are the kind of things we covered. So have a think about what you need to transfer, and so on. And you won't come to, if you don't come to anybody's notice, that's a good thing. Okay. I think that's all very clear. And just for the last few minutes, we'll have a quick look at a safe. Hopefully, again, most of you are fairly familiar with this stuff. It provides you a mechanism through which you can keep track of the details of your account. If you need a new password, you can reset your password through there, and you can request access to licensed software with appropriate license details for packages you're interested in. So I think, so hopefully you've seen all that. There's a user guide available if you want a reference. So one of the things that you will have seen, for example, in my case, I now have quite a lot of different accounts related to various different activities, and so this gives you a way to track all of these. So, for example, if you have different strands of work associated with different projects, you may have an account for each one of those projects. You may even have accounts on different machines, which you can track with this mechanism. Just a couple of features. If you're interested in using institutional single sign-on, you can do so. You can also, perhaps more usefully, change your preferences for which type of email notifications you get or do not get. So you've all seen picking up your initial password. Hopefully, as I say, you can reset your password if you need to. So one of the things it's possible to do is to add additional SSH public-private key pairs, or the public part. So, for example, if you have a machine at work and another machine at home, when we all get back to work in a regular fashion, you can add one credential for each. Is one way to make sure you have access from each. The other thing it's possible to do is to record research outputs. So particularly if you're higher up in a project, you may be interested to register your outputs. Outputs may include publications in refereed journals. If you have a DOI for software, that could also be an output. So it's helpful for us in our accounting to the research councils to have evidence that useful things are being done. So the more evidence we have, the better the long-term future for HPC services in the UK. Okay, so I think at that point I'm going to more or less stop talking for today. I will hang around until 5 o'clock to answer any questions which you might want to type into the chat, but we'll start again at 10 o'clock tomorrow morning with the debugging and profiling section. So I may even rejig this web page to reflect that. Okay, so hopefully today has given you enough to get going with whatever work you're doing. With that, I'll say thank you everybody for attending, and we will see you again tomorrow.